The views expressed on Skeptically Speaking are not necessarily the views of this station, its affiliates, sponsors, or advertisers.
Bring it on, the skeptics await your letter. Your call, tweet, homing, pigeon, whatever. Desiree Shell gonna raise a little hell, metaphorically that is. Cause we're skeptically speaking.
Hello and welcome to Skeptically Speaking. I'm Desiree Shell, and this week we're talking about forms of life that are completely different from anything we've seen before. Later on in the show, we'll discuss the ethics around trying to contact life on other planets with IO9 contributing editor George Dvorsky. But first off, let's figure out what we might mean by life. I'm here with David Toomey, an associate professor of English and director of the Professional Writing and Technical Communication program at the University of Massachusetts-Amherst. He's the author of The New Time Travelers, A Journey to the Frontiers of Physics, and Storm Chasers, The Hurricane Hunters and Their Fateful Flight into Hurricane Janet. He's here to talk about his new book, Weird Life, the search for life that is very, very different from our own. Welcome, David.
Thanks for having me.
So after reading your book, it has become very apparent to me that every time that we try to define what life is, we are wrong. Would you agree with that?
I would. The history of attempts to define life is very long. It may predate philosophy as we know it. There have been two ways to define life. One is a functional definition by what it does, and if we try to add up the things life does, we come up with is born, lives, has some sort of chemistry that keeps itself going, and after a fashion dies. It also perhaps converts matter to energy in some ways. But one could say that stars and candle flames do all those things, and few of us would call them living. On the other hand, there are organisms most of us would agree are living that run up against a problem with definitions of the functions of life. Most of us would add another function to life that stars and candle flames don't do. We'd say life reproduces, and yet there are a number of organisms, we'd all agree, are organisms that don't reproduce. These are mules and worker ants come to mind. So the functional definition, of life is very difficult.
Well, yeah, we'll go to an easier one because you do provide a definition for weird life. So what's that?
We need to understand what weird life is. We have to back up and explain what life is. And what familiar life is. That is all life that we know to exist. All life we know to exist has in it DNA, it has enzymes and proteins, it has the same biochemical processes going on. It is made of the same amino acids and the same basic chemicals. Moreover, it's all related, and biologists know it's all related because of these shared features. It is all life, all organisms, all individual species have a place on a single phylogenetic tree. That's the common representation of all life we know, and all of it shares or springs from a single root. It all has a single common ancestor that biologists call the last universal common ancestor, or LUCA. LUCA is a theoretical organism that biologists believe must have existed some 3.5 billion years ago. So that's life we do know. That's familiar life. Now, weird life would be any life that is not on that phylogenetic tree and is not descended from LUCA.
That's actually fairly simple.
Okay.
So, well, let's start talking about weird life as close to home as we can. We used to think that there were physical boundaries within which life is possible, and then outside of those boundaries, there could be no life. So what kind of physical boundaries are we talking about here? Like above and below certain temperatures, and what else?
Until about the mid-1970s, most biologists believed that life could not exist above certain temperatures and below certain temperatures and above certain pressures. And they believed that life could not stand certain amounts of salt, certain amounts of acid, That is to say, in its liquid environment, if it existed in a liquid environment, they believed that life could not withstand certain amounts of radiation, and in all those cases, since the mid 1970s and right up until this week, probably, scientists have discovered forms of organisms that did those things, that broke those boundaries.
And so we're talking about extremophiles here.
Exactly. Those literally lovers of extremes.
Well, maybe give us some examples. I find the hydrothermal vent communities fascinating.
I do too. The hydrothermal vent communities are those organisms, the tube worms and the white clams that were discovered in the 1970s by, as it happened, two geologists who weren't really looking for them. And they were 2 kilometers deep in the Pacific, and they were living. They surrounded a hydrothermal vent, that is a crack in the ocean's floor through which was issuing very, very hot, scalding hot water. And not only was the water hot, it was also under enormous pressure, and it was startling to find a thriving ecosystem in the vicinity of the hydrothermal vent. These exist all over the ocean floor.
One of the reasons why I love this so much, this discovery, is because that discovery led to so many more extremophile discoveries.
Right. The dam seemed to break at that point. Biologists started looking, well, they recognized that hydrothermal vents offered quite an environment. They were hard to get to, though. A couple of kilometers deep on the ocean floor is not a place that's easy to visit, but you could find them on the Earth's surface. In Yellowstone National Park, those hot springs, the discharge from those hot springs is full of microbial communities of various interesting sorts living in water that no biologist really expected to find it in. Many biologists started looking even at their history. They'd overlooked many things were in common sight. There was microbiologist in the 1930s named Benjamin Volcani, who was studying microbial communities in the Dead Sea, which I have to say is quite the misnomer. It is anything but.
This concept itself is interesting. If people don't think something can exist, they usually have no reason to look for it. And so these discoveries, at least the hydrothermal vent communities, it was a discovery made by accident.
It was geologists really who found it, and they were investigating the ocean floor in the Pacific, a few hundred miles west of the Galapagos Islands, and they made pictures of white clams that were obviously living and obviously 2 kilometers deep. That was, they really stumbled on it. The microbes at Yellowstone National Park, everyone had seen those, of course, for years and years, but no microbiologist seemed to put 2 and 2 together, or seemed who happened to, or maybe no microbiologist saw them, but anyway, and thought much about it. But then a few people did.
So now, extremophiles, maybe on the whole, I don't know if we can speak for them as a classification, but did extremophiles originate in those extreme conditions, or did they adapt to them? Or can we even remotely answer that question?
I think no one can really say, but there are some very, very workable theories that say they began there. In fact, that perhaps there are ideas of the origin of life on Earth, and many theories, many competing theories. But one of them is a respected theory, is that some of it at least may have begun where extremophiles live. This is because 3.5 billion years ago, that would have been, much of the Earth would have looked like the vicinity of a hydrothermal vent community. And they may be very, very old organisms.
You're tuned in to Skeptically Speaking, and I'm talking to David Toomey, author of Weird Life, the search for life that is very, very different from our own. Okay, so we've established that there are species on Earth that are very odd, but they're not weird per se, according to your definition. Weird meaning they don't originate from a common ancestors. So, but some people do think that there might be weird life on Earth in something called the shadow biosphere.
The shadow biosphere, that's a term invented by a philosopher Carol Cleland and a colleague of hers. And shadow biosphere means a biosphere that is akin to the biosphere we all know and love, and in some ways living alongside it. In the book, I compare it to fairies beyond the hedgerow, kind of a little bit spooky, but and quite a bit strange, but also nearby. Well, it's possible that a number of microbiologists and others, Carol Cleland, Paul Davies, I should say, is a physicist, and Carol happens to be a philosopher. They have explored, they have thought about this in some detail, and thought about generally the places that organisms composing a shadow biosphere might exist.
Well, so what we're talking about here is basically a life originating on Earth twice?
Yes. If the shadow biosphere, I should reiterate, is hypothetical.
Right.
But if organisms do compose a shadow biosphere, they would have descended from a different common ancestor, and that ancestor most likely lived and breathed and pulsed and at a different time than did Luca. Maybe later, maybe earlier.
How might that have happened?
To answer that question, which may be an impossible question to answer right now, the question is in effect asking, how did life happen? And no one really knows the answer to it, and maybe no one ever will. There are two, one should say, competing points of view here. One is that life is rare and perhaps unique on Earth, and that would be because life is the consequence of a very, very improbable combination of chemicals that the combination so improbable it could have happened, is likely to have happened only once. Another view is simply that life is the inevitable product of complex chemistry. So anywhere you have chemistry, chemistry quite naturally becomes more and more complex all the time. As long as there's energy and chemicals around, those chemicals will react and keep reacting and make things make molecules that are bigger and bigger and more complex. And that point of view says that life is inevitable everywhere. There's chemistry, and that point of view would support the beginning of an organism that composed a shadow biosphere, or I should say that point of view would support the existence of a shadow biosphere.
Given that it's entirely theoretical, wouldn't we have noticed something like that by now? And I mean, by we, I mean microbiologists.
Great question. And the answer is not necessarily. The reason we wouldn't, this came as something of a surprise to me as I began researching the book. There's a great deal that we do not know about life on Earth. In fact, we know very little about life on Earth. We don't even really know how many species there are. We can't even make a realistic close estimate to how many species there are, and the range of estimates varies wildly. When we talk about microbial life, and I should say that weird life in the shadow biosphere, the assumption of everyone here is that is microbial life. We know even less. If you walk outside and take a pinch of soil from outside your kitchen door, much of the life, much of the organisms, the microorganisms in that pinch of soil are unknown to science. So the proponents of the shadow biosphere idea would say it's not at all improbable that some of the organisms in that pinch of soil are of a shadow biosphere.
Didn't we think that we might have found the product of a shadow biosphere a few years ago in the form of bacteria that replaced some of its phosphorus with arsenic? That was all over the news.
That was an investigation conducted by Felissa Wolf-Simon, and she had an idea that there might be a kind of bacteria that was using arsenic in its DNA. All of our DNA and all familiar life uses phosphorus, not arsenic. She collected a number of samples from Mono Lake in California. That is a lake that is very, very brackish, known to have life and known to have a lot of arsenic in it. So it seemed like the place to look. she conducted a number of experiments in which she starved any organisms she believed she had in her samples. She starved them of phosphorus and left the arsenic in, the nutrient dish. That is the stuff she was feeding the bacteria with. And just looked to see what survived. She and her group did make a claim that they had discovered bacteria that had replaced at least some of the phosphorus in its DNA with arsenic. And unfortunately for the believers of Weird Life, that claim turned out to be disregarded and held in fairly low regard by her colleagues. That result was never replicated.
We've definitely talked about what became known as Arsenic Gate on the show before, because it became a huge debate about the nature of peer review, actually, and science blogging's position in that process, because there was a blogger named Rosie Redfield fighting to be taken seriously when she was criticizing the research, which is fascinating. But that would have offered some kind of evidence towards the shadow biosphere theory. So how much support does that idea have among mainstream scientists?
That's really hard for me to say. One way one can gauge that is to look at the papers and see how many and how many have cited it. And I think, frankly, not a lot. Another way to gauge it is to see, is there any ongoing study? Is there a program, a dedicated program, to look for alternate life forms or weird life on Earth? And in fact, there is none. Although Paul Davies and several of his colleagues, the authors of the paper, have suggested. So I think the short answer is not a lot.
This is Skeptically Speaking, and we'll be back with more of David Toomey and his book, Weird Life, the search for life that is very, very different from our own, after this.
Skeptically Speaking is rebroadcast on a number of fine radio stations. To find out where Skeptically Speaking airs near you, to listen to past episodes, or download the weekly podcast, check out our website at skepticallyspeaking.com. While you're there, follow the links to connect with us on our Facebook page, our Twitter feed, or to subscribe to the show in iTunes. And now, back to the show.
Welcome back to Skeptically Speaking. I'm Desiree Schell, joined by David Toomey, the author of The New Time Travelers and Storm Chasers, and he's here discussing his new book, Weird Life, the search for life that is very, very different from our own. Okay, so let's go off-world. How likely is it that we might find life out there? And you can't see my air quotes, but out there.
Again, that's a nobody knows kind of answer, I'm afraid. The people who believe, and there are many people who believe that is quite likely, believe that because they believe that life is an inevitable consequence of complex chemistry. And the people who think it unlikely because they think life is the product of an incredibly long and complex chain of events, and may have happened only once or very few times.
Well, let's talk about what exactly we're looking for, if we were looking for it out there, as it were. One of the commonalities with life on Earth is that every place that liquid water has been found, so has life. So is that correct?
Almost. There are temperatures of water and pressures of water that seem to prohibit life, but pretty close. It is a fair generalization to say wherever there's water, there's life, and vice versa.
So what's so significant about water then?
Water has many virtues for something living. The range between its freezing point and boiling point is very wide, and that's good if you want to move a lot of molecules around and have them interacting. That means you can do it at more temperatures. I'm comparing water here to other chemicals. Water has surface tension, and with surface tension you can make bubbles and things like bubbles may have been precursors to cells. Water is a great solvent, meaning it breaks up molecules readily, and it also it also, well, simply because it is a liquid, it allows those molecules to move around and interact with each other. And you want both of those things if you're going to have complex chemistry and possibly life. One of the most interesting and unusual characteristics of the water is that it expands as it freezes. And because it expands when it freezes, lakes and parts of the ocean in colder climes on this planet have a surface layer of ice, and that surface layer insulates the water beneath it that doesn't freeze. So if water, like most liquids, if water became heavier when it froze, it would sink. Many lakes in colder climes and oceans in colder climes would freeze all the way through, and life in those places would be very, very difficult. In fact, that particular quality of water was thought by many 19th century philosophers to be evidence for a deity.
How so?
This would be a deity that wanted life. If a deity, I should say, working backwards. If you want oceans with fish in them, you're going to need to make those oceans of a liquid that when frozen does not sink and freeze all the way through. A liquid that when frozen becomes a little more voluminous and a little lighter and affects a surface layer of ice.
So then if we are looking for life elsewhere in the universe, are we primarily concerned with trying to figure out where there might be water, or are we looking for other things as well?
NASA's policy for looking for life, if there is a policy, or NASA's thinking about where to look for life really is a presupposition is if we look for water, maybe there'll be life. And that has been for instance, why NASA is not bothering to send probes to Venus or Mercury to look for life, why NASA is not bothering to send probes to the moons of the outer solar system to look for life. It's why NASA is interested in Mars, where there is enormous evidence of water flowing on the surface in the past, and much evidence of water, frozen water and liquid water too, subsurface. It's why NASA is also interested at a more distant and ambitious prospect, that is the moon of Jupiter called Europa, which is believed to have a great subsurface that is beneath its ice, ocean of water that may be very, very brackish, but it is water nonetheless. And NASA's interested in both those places.
Well, and see, this is the thing, though. If a species, and I know this has been said about 1,000,000 times by 1,000,000 people, but I'm going to ask it again because I'm still interested. If a species was very different from the ones that we already know, truly weird life, so different that we can't possibly imagine their metabolisms and what they might need to survive, might we be looking in the wrong places for them?
We very well might, and a number of astrobiologists have suggested it as much. A place a few are very interested in is the moon of Saturn called Titan. And on the surface, Titan is a very, very mysterious moon, and it has its atmosphere is utterly opaque, and no one saw anything beneath it until the Huygens probe was landed there in 1995. And what's many things are very interesting about Titan. It is thought to be the most Earth-like of anybody in the solar system, and there are liquids on its surface. It's far too cold for liquid water on Titan, but there is a water ammonia slush, and there is liquid methane. And those are chemicals and chemical compounds that on Earth, of course, would be gases. But it's precisely because there are liquids on the surface of Titan, and liquids that even now seem to be shaping the surface of Titan. There seem to be streams there. There seems to be rain. There are clouds. There is a lot of there's real weather on Titan. But there certainly could not be life as we know it, because life as we know it needs water.
Since we're already on the me complaining topic, I might as well talk about my issues with SETI, because it's a similar problem for me. If a species is completely unlike us, especially talking about a potentially intelligent species, okay, just between you and I, do you ever get the feeling that somehow we're doing it wrong? Like we're just overlooking these minute... The idea of the shadow biosphere actually makes a lot of sense to me, because we are so unaware and unfamiliar with what could be out there that I feel like sometimes we're looking for the wrong things.
Paul Davies wrote a book a couple of years ago called The Eerie Silence, and he talks about this. He addresses this question somewhat. In my book, I put together a couple of ideas from a number of people. One reason that there might be more weird life than familiar life is, by familiar life we mean life that lives in water, life that needs water, and is on a planet somewhat Earth-like, at a distance from its sun, about the distance Earth is from the sun. Maybe there's a lot more of another kind of life that would live on Saturn's moon Titan, and that is because there are a lot more red dwarf stars in the galaxy than yellow stars like the sun. And red dwarf stars, maybe 10 times more, maybe 100 times more. No one really knows. But if that's the case, and if planetary systems are distributed equally among all stars throughout the Milky Way galaxy, then if you had a planet orbiting, say, at the distance Earth is around a red dwarf star, which is much cooler, it would have the temperature that Titan has. So you see, you'd have 10 to 100 times at least more Titan-like planets than Earth-like planets in the Milky Way galaxy. And if that's the case, it would follow that you'd have 10 to 100 times more chances for life on a given world. And thinking like that would suggest, yeah, there's more weird life. It's also possible that there's a lot of intelligent life in the Milky Way galaxy that really just doesn't get technical and doesn't bother building radio telescopes for whatever reasons. And the SETI folk, they would say, well, we certainly don't expect to hear from them.
You're listening to Skeptically Speaking, and my guest is David Toomey, author of Weird Life, the search for life that is very, very different than our own. So since we're very much obviously on the speculative end of the weird life spectrum, we might as well jump straight into the multiverse, and I know this is going to hurt me. So what is it, and what might life be like there?
The multiverse is an idea an idea for a cosmos, one should say, that is everything, that has been proposed by physicists and astrophysicists in recent years. There are a number of kinds of multiverses, but the old idea of the universe was that there's only one, and that's all there is. So to speak of a multiverse almost seems to defy language. How can anything be outside a universe, since a universe by definition means everything, right? But there are ideas of many ideas and types of multiverses, maybe 6 or 7 different types. But one of them is that one imagines at the very beginning a big bang, a bigger bang, the biggest bang preceding the Big Bang. The Big Bang was only the creation of the universe, the beginning of the creation of our universe. But there were others, many others, perhaps an infinity of others. And what results is, well, the easiest metaphor is a loaf of rising bread. And in a loaf of rising bread, there are air pockets, there are bubbles of air. And as the bread expands, the bubbles get to a certain size and stop expanding, but they get further and further apart. Each of these bubbles would represent a separate universe. And in each of these bubbles, what's among the many curious features about universes within the multiverse is the fundamental constants of nature might be different. no physicists really thought much or questioned, I should say, the fundamental constants of nature until about the late 1970s. Fundamental constants of nature meaning things like the strength of gravity, which has a particular strength. And a lot of people, even physicists, never really thought much about this. And never even thought to ask, why does gravity have this strength and not another? Why isn't it stronger or weaker than it is? Questions, too, about the material of the universe. Why do atoms have the three types of quarks they do? Why are they made of those three quarks? Why is a photon what a photon is, or a neutron what a neutron is? Meaning, why do they have those particular atomic weights? Why aren't they heavier or lighter than they are? And one answer, which is a very unsatisfying answer to many people, one answer was that if you change these fundamental constants a little bit, you couldn't have life, which is kind of a kick in the head. And we have to take a deep breath to get past that one. What that means in the case, say, of gravity was slightly stronger than shortly after the Big Bang, the mutual attraction of all the particles that were radiating away from each other, the mutual attraction of their gravity would pull them back. So the bang would have banged, and a second or less than a second later, it would have collapsed on itself. If gravity were only a little stronger, if it were only a little weaker, then the particles of the universe would have had much less mutual attraction for each other, and we'd be living in a universe of hydrogen gas. Of course, we wouldn't be living in a universe of hydrogen gas because there'd be no us. There'd just be a universe of hydrogen gas. So the fundamental, the strength of gravity, why it is what it is, was answered by a few philosopher physicists, one might say, by saying we're here. The strength of gravity couldn't be otherwise. Now, of course, it could be otherwise in another universe. And in that other universe, we wouldn't exist. No life would exist. If it were weaker, that universe might be a universe of diffuse hydrogen gas, for instance. Some theoretical physicists think the better answer to gravity's strength, has the strength it is, don't ask anything about it, just shut up and live with it. We're here. We should be happy about that. The better answer is we're lucky. It could have been otherwise. And in fact, it is otherwise in most of the other universes.
But then that being said, if the rules are different, then wouldn't that mean that any kind of life would be possible?
Yes, it would. Just about any kind of life. Here's where we step way off the curb.
We didn't do that already?
We've probably crossed the street by now. There may be. I talk about this briefly in the book. It may be impossible to have life with only two dimensions in a universe with only two dimensions. Other than that, yeah, the answer is yes. Just about. If you have an infinity of universes, of course, you are necessitating an infinity of possibilities. And among those possibilities, clearly, there has to be, by necessity, an infinity of types of organisms. Some of them, many of them, weird.
To be clear, no one has, to this point, found any example of truly weird life. And we have been looking in a number of places. It's possible that even with all the research in all these different areas, we might never find it. So are there other benefits of looking for weird life even if we don't find it?
Yes. A lot of ideas about weird life, when scientists have thought about it in detail, have to speculate in detail and hypothesize in detail, had to base their speculations, or I should say, have found it useful to base their speculations on earthly organisms. Which is to say, for instance, Carl Sagan and a colleague, Edwin Saltpeter, hypothesized incredibly large, helium-breathing beings floating in the atmosphere of the planet Jupiter. In fact, they imagine a whole ecosystem of these beings being born, living, going through their entire life cycles. As Sagan used to say, he'd like to talk about this. He'd say beings the size of cities, but they would look like dirigibles. And as strange as that is, the ecosystem that he and Saltpeter imagined mirrors the ecosystem of phytoplankton, that is, the plankton that live and thrive in the sunlit reaches, the upper reaches of oceans of the world. And that another example of hypothetical weird life. Astronomer and science fiction author Fred Hoyle imagined a sentient interstellar nebula, and it worked the way the human brain works. And so he too, like Sagan and Saltpeter, had to, one might say, appeal to known organisms. If we're to understand life on Earth, that is familiar life on Earth that we know, or understand it better, or understand its particular organisms better. And this is certainly a time in history when that would be a very, very good idea. Then weird life, or thinking about weird life, at the very least, gives us a new perspective, which I think would be a welcome perspective.
David, wonderful to have you here.
Thank you.
You can find David Toomey and his book, Weird Life, at the link on our website at skepticallyspeaking.com. This is Skeptically Speaking, and we'll be right back with Canadian futurist George Dvorsky after this.
On the next episode of Skeptically Speaking, guest host Marie-Claire Shanahan spends an hour exploring knowledge and certainty with scientists who study how they change over time. She'll speak to Samuel Arbesman, applied mathematician and fellow at the Institute for Quantitative Social Science at Harvard University, about his book, The Half-Life of Facts, Why Everything We Know Has an Expiration Date. And we're joined by computer science and biology professor Mark Daly to discuss the value of using computational thinking to better understand everything from biology to music. That's next week on Skeptically Speaking, on your local radio station, or online at skepticallyspeaking.com.
Welcome back to Skeptically Speaking. I'm Desiree Schell, and I'm joined by George Dvorsky, Canadian futurist, science writer, and ethicist. He's a founding member of the Institute for Ethics and Emerging Technologies and the founder and program director for the IEET's Rights of Non-Human Persons program, an initiative to see extended rights and protections granted to highly sapient animals. He's also a contributing editor at the online news blog IO9 and a blogger at Sentient Developments. And it's always nice to have you here, sir.
Always wonderful to be here. Thanks for having me again.
After the interview with David Toomey about weird life, I couldn't help but have the same conversation with myself that I always seem to have when these kind of topics come up, and that's basically, why are we trying to contact intelligent life in the first place? Because if they're advanced, they're probably going to enslave us, and if not, we'll probably enslave them. And I absolutely realize that that is not only overly simplistic, but also terribly pessimistic. So George, I need you to help me through.
I think we're largely on the same page, actually. I mean, I also have a certain degree of pessimism and concern when it comes to this particular initiative, or at least clarifying what we're talking about here. There's a big difference between what SETI is doing, which is the search for extraterrestrial intelligence, and METI, which is messaging to extraterrestrial intelligence, or it's also referred to as active SETI, which is actually trying to make our presence known to any potential alien civilization that might care to listen or might be looking for these sorts of signals. And by signals at this point, really what we're talking about are radio signals. Now, what SETI normally does, it's passive search. We're just sitting here with our radio dishes, and we're just listening for any kind of a radio signal that may be indicative of some kind of an intelligence. So, really, that would just be information that we would know. Oh, that's interesting to know. Let's say that within 5 light years or 20 light years, there is somebody potentially out there. But there is a whole world of difference in this kind of idea of broadcasting our presence in a very deliberate and targeted way. Yes, there are, right now we are what's called leaking radio signals just from our regular, broadcast transmissions and satellite transmissions and so forth. But it's these signals are very weak. They're untargeted, and they could very well just dissipate out into space without anybody finding them. But as time goes by, and as a recent initiative has shown, there seems to be an interest in actually creating what would be targeted, high-powered radio signals with very specific messages that are designed to get attention. And if those messages were ever to be received, we absolutely have no possible way of doing any kind of a risk assessment or any kind of an analysis on how those messages would be interpreted and the kind of reaction we could expect in turn. Knowing full well, I mean, not that I want to dwell on the kinds of science fiction portrayals, because science fiction can oftentimes be very distracting and be very lead us down these kinds of paths that are not, let's say, fair or accurate. That being said, it's the dearth of information that concerns me, and it concerns a lot of my colleagues, that we really should probably, I would say, hold off a little yet in terms of making ourselves that obvious in our area right now.
So I am very much on the same page as you. This is concerning to me. But that being said, not everyone is on the same page. And there's a lot of people who think that we should be sending out these messages. And I don't know. I think they might be overly optimistic at the response we may get.
Yes, and I think you're speaking specifically of the recent Lone Star program, yes, which that's Jacob Hackmisra's project. And basically, it's a conglomeration of astronomers and, I guess, astrobiologists and entrepreneurs. And what they've done is they've repurposed the Jamesburg Earth Station radio dish, which is in Carmel, California. And they've basically set what is going to be, what will go down in history as the world's first continuous beacon that will be sending messages into space for the deliberate purpose of attracting the attention of an extraterrestrial civilization. And specifically what they've done to start off the project, because it actually started a couple of weeks ago, is they're targeting the Gliese 526 star system because it's deemed to be the closest star system to our own that has the potential for habitability. And what habitability means that it has terrestrial planets, like rocky planets like Earth, that happen to reside within its so-called Goldilocks zone. So it's not too close to the sun, it's not too far away from the sun. It's in that nice little sweet spot where water can exist as in liquid form, and where it can have a complex atmosphere that's also conducive to the emergence and fostering of life. So so in other words, it's a very specifically targeted star system, and I do believe it's within about 5 light years or so, if memory serves. So it's 5 light years is obviously a ghastly distance, right, but from a cosmological perspective, that's pretty damn close. So they're targeting that system specifically, and they've already started to send messages out there. Some of them are their very own. These are messages designed by scientists, and they actually contain schemes and patterns that would be very indicative to an advanced civilization that this is not a natural phenomenon, that this was definitely something produced by an intelligence designed to get attention. That's the first thing that they're doing. The second thing that they're doing is they're opening it up to the general public, and that for a fee. And they got even packages that range from 99 cents will get you 4 credits to $99 will get you 4,000 credits, and you can start to send your own particular messages into space, like "Hello, aliens," or how's it going? Even people are even sending things like animated GIFs and so on out into space. So that's obviously their revenue model, and which is somewhat alarming for those of us who are concerned about the potential for this project to be somewhat risky, or at least premature. Let's put it that way. At the risk of overstating, I think, the kind of paranoia that might sound like I'm coming from.
That's the realm that I'm dealing with here. Am I feeling paranoid, or am I just concerned about things because we don't have all the information? Yeah. And I think part of this too is what kind of intelligent life are we talking about? Are we talking about intelligent life where they are as advanced as we are, or are they more advanced? Is our reaction different to those?
I would say that SETI is, and this was kind of set up by Frank Drake back in the 60s, and it's largely been the philosophy since then, is we're actually just passively listening for radio-capable civilizations, which would actually be indicative of a civilization that's pretty much equal to our own in terms of its technological sophistication. And which is interesting because back then they certainly wouldn't have known this, but we are in short order about to become radio silent. We are replacing our radio signals with other types of communication signals that aren't going to be as leaky. So I think that the traditional SETI model is definitely looking for civilizations that are equivalent to our own. But that being said, obviously, if we can continue to, let's say, use targeted beams of radio signals that are deliberately meant to attract attention, then we're talking about any kind of civilization that's equivalent to our own and greater. By the way, this isn't just limited to radio. We can also start to use things like laser beaming and other basic any kind of beacon that would be obvious. One example for that's interesting is the idea of creating massive artifacts with very obvious geometrical shapes, like a perfect square or a perfect triangle, and start to put it in orbit around the sun. So by using the transit method, an extraterrestrial civilization would say, "Wow, that's definitely not natural. That's definitely a sign of it's like a beacon or a calling card." So there's many different ways. There's even, for example, they can look at our spectroscopic imaging that's reflected from the Earth from our sun, and they would be able to determine our atmospheric composition. So they could tell, for example, that because there's elevated levels of oxygen, that there's likely life on there, or even more so, there's elevated levels of carbon dioxide and other signatures that could be indicative of post-industrial civilizations as well. So there's many different ways. But back to your point, another potential thing that they could do is, and this is definitely getting into the realm of speculation, but it would point to the sophistication of the civilizations that we could potentially be alerting, is the idea of seeding the galaxy with probes. This was an idea that was proposed as far back as in the 1950s and 60s by John von Neumann, and they've now named these sorts of theoretical probes after him, the so-called von Neumann self-replicating probes. And these probes can be given any kind of task, whether it be exploratory, whether it be even colonizing probes, but they could also be communication probes. And this is what's referred to as a Bracewell probe. So there could be probes, for example, peppered all over the galaxy. And again, just as a word of clarification, the galaxy is old enough, it's quite ancient, and we are actually very much latecomers to the show here, that the galaxy could very well have been explored and peppered by these probes many times over by now. So this is kind of one of the assumptions that we have to go under. So my concern is, and again, I know I'm keep digressing, but back to your initial point, is that these probes could be sitting idle in our solar system or relatively close, just waiting for any kind of sign of an intelligence, and then it will act accordingly. It could be very friendly, like it very well could be, or it could be very malicious. It could be very much a concern about these new intelligences emerging in the vicinity, because they don't know what kind of intelligence could emerge from the planet Earth when it becomes very very powerful. And again, just to maybe provide some more specifics, I'm sure many of your listeners are familiar with the term or the concept of a technological singularity. This would very likely be the nature of an advanced extraterrestrial civilization. So that's the concern I have. Is to kind of, again, to answer your question, is that we run the gamut. Desiree, we run the gamut in terms of who we could actually potentially alert by having these sorts of targeted active SETI type initiatives.
I've heard the opinion that we might as well try to get into contact with intelligent species, because if they are at the point where they have both the technology to respond and the means to make their way here, then they eventually would have found us anyway, and we might as well. And I guess we should just start off the diplomacy process now.
And I think that's a very good point to bring into the conversation. And at the risk of sounding all overly, again, pessimistic and paranoid, Carl Sagan was very much a proponent of this idea, and he's what's referred to as a contact optimist, and a contact optimist in two different contexts. One, he was convinced that the galaxy contains many intelligent civilizations, but also a contact optimist in the sense that they are more likely than not to be benign and friendly. And his reasoning behind this was that he said, look, any civilization that's capable of surviving existential risks, like apocalyptic type risks, like a nuclear war and any other futuristic kind of apocalyptic technologies, that they will have kind of figured it out, that they will have come to some kind of a political and socio-political arrangement that would have resulted in their survival rather than their destruction. And that was his hypothesis, and many people have decided to run with that and work under the assumption that that they're more likely to be friendly than not. And again, this is in a way one of the things that was discussed by Jacob Hackmisra, and this is again the fellow who is the co-founder of the Lone Star Active SETI project. He's wondering, like, what could the potential benefits be from actually, making contact with extraterrestrials? And one can imagine, for example, that they would have much to teach us, much to help us with. I mean, we're pretty stranded here on Earth. Like, we're not just stranded, we are absolutely stranded here. We are absolutely isolated, completely alone. We are trying to figure this out for ourselves, and we may not actually survive, our technologies and ourselves. We certainly could be contacted by, let's say, a Carl Sagan-like civilization, and they could help us figure it out, help us survive ourselves. And this even was referred to by the sci-fi novelist as uplift, that they could uplift us. They could help us transition to, let's say, the next phase of civilization. And that by not, let's say, advertising our presence here, we run the risk of being abandoned and forgotten here. That maybe there's a wonderful galactic club happening out there that's invisible to us, because clearly it is. I mean, looking up into the sky, it appears to be completely empty of life. Maybe these things are invisible to us in sorts of ways because of the limitations of our technologies, a kind of selectional effect. I mean, even if they never are able to visit us, let's say, maybe we can establish some kind of a communication schema. Again, right now, obviously, the speed of light being a very terrible limiter here, and that's a very long distance conversation that would take obviously many, many years to have meaningful back and forths. But perhaps there's other kinds of communication schemes we don't know about, something involving, let's say, quantum non-locality and other highly speculative things like that we could share information and have some kind of cultural and scientific transmission that would work to our mutual benefits. Again, these are definitely things that we need to consider. But it needs to be part of the broader conversation. We need to likewise talk about the risks. And for example, a communications exchange and a cultural exchange may actually be quite catastrophic. There may be, cultural and religious groups here on Earth that, regardless of the makeup and the nature and the intention of extraterrestrials, would be very alarmed by that. It would be very disruptive. It could overturn their belief systems and their values and so on, and it could result in even just further turmoil here on Earth. So these are the kind of like side effects that we need to discuss.
And that's one of the things that is so concerning to me, because I am, obviously most familiar with the human species. And let me be absolutely clear about my position. I do not trust humans to meet another species and not immediately try to exploit them if we had the chance. So, if I'm going to anthropomorphize a species that I don't know anything about, I can only extrapolate that they would respond in the same way.
That's a fundamental question that definitely deserves, it's also a kind of one of the most common arguments set against the problem that we have not yet made contact with extraterrestrials when we apparently should have, according to Enrico Fermi and his calculations, is that the common argument is like, why? Why would they come here? What in the world could we possibly have to offer them? We're boring. We'd be technologically behind them, and that there's really nothing for them to gain by contacting us. And that bothers me to a certain degree, and yet I'm also somewhat partial to that line of reasoning. What would we have to offer them? I mean, aside from just scientific interest or even the cultural kinds of exchanges, certainly I do believe that we would have nothing technological to offer them if they're capable, let's say, of coming here, or if they're actually capable of even transmitting something meaningful to us. But there is also concern, for example, again, amongst some, I guess, some thinkers that there would be this kind of colonization wave where they would convert all of the matter in the solar system into some kind of into something that would work to their benefit, that it's what's so-called computronium. In other words, if we're talking about advanced, like super advanced extraterrestrial intelligences, they're very likely not flesh and blood. They're probably machine-based at this point and largely computational, and they would be building mega-scale computational objects that basically provide for them more and more and more computation. So what they need is matter, because in order to flip ones and zeros, you need matter, you need stuff. So the idea is that they would come here, not necessarily looking for us or for any kind of technological or cultural benefit, but they simply want to convert every single scrap of matter that exists in our solar system into something that they can use to work on their mega projects. But that being the case, if they wanted to do that, they should have probably done that by now, and that's because irrespective of whether or not there's life in the solar system or not. Unless, of course, you're partial to a kind of Star Trek Prime Directive, where the reason why we haven't been contacted yet is because they have a hands-off policy. Because there is life here, and not only life, but there's intelligent life here. They're absolutely keeping their distance, and letting us develop on our own until such time as maybe they feel that they need to get into touch with us. And again, one of the things that I worry about is that they won't like what they see once we emerge, let's say, from a post-singularity kind of transition.
Exactly.
And that, for example, it's kind of what we've dubbed the whack-a-mole hypothesis, is that they're here in the neighborhood either through their probes or it's also referred to as berserker probes. Berserker probes being basically exactly what it sounds like. It would be just some kind of a technological device that would sterilize the Earth should it decide it doesn't like what it sees. So let's say when it comes to, let's say, speculating about a post-singularity intelligence, it's not just, there's the potential for not just one type. There's a potential for a whole spectrum of different types of intelligence that are, let's say, post-singularity survivable. And some of them might be benign, but some of them might be insanely evil. And they may be basically sitting over us with a kind of mallet and basically waiting for the singularity to happen here, or whatever you want to call it, like a phase transition, I think is a better phrase than singularity. I actually hate the word singularity, but it's what it seems to be what we're using. But anyways, let's say the kind of machine intelligence that emerges here is one that's evil and set on, let's say, some kind of intergalactic colonization scheme that would, work to sterilize other life and whatever. That for whatever reason they don't like what they see, they would whack down that anvil, or sort of whack down that mallet on the Earth and prevent us from basically progressing any further. Or it might absolutely love what it sees. Maybe we're going to be exactly that kind of benign, enlightened type of civilization that it wants to interact with, at which point it's going to do it. We'll do a meet and greet.
You mentioned the word evil, and that I think is problematic as well, because can we think in terms of morality at all if we're talking about a species that might be completely unlike us?
You're right. And this is what we get into, is this discussion of what's called meta-ethics. Is how can we even begin to do a kind of is there any kind of a universalist ethical MO that we can even ascribe to these kinds of intelligences? At this point, I think you hit it on the head earlier by saying that we're anthropomorphizing, and we're certainly projecting our own values right now on ETIs for the needs of a biological organism like ourselves that's in a post-industrial phase, could be what we value and what we care about could be vastly removed from what, let's say an advanced ETI values, or what a post-singularity civilization values. So what we would call quote unquote evil could actually be a very important kind of injunction, or a very kind of important set of values for an extraterrestrial civilization. One thing that I've speculated about, not just myself, many have, is that from a utilitarian perspective, we may find, for example, that the most valuable thing in the universe is the creation of valuable, worthwhile existences or lives. And that's, for example, so in other words, the more positive experiences that you can have, in other words, the more entities or agents that you can have that live worthwhile existences, and the more of those that you can create, then the better. So you could conceive of a scenario in which some kind of advanced machine intelligence would wish to convert, again, all of the matter in the universe such that it's not inert, but it's actually conscious, aware, subjective, but living worthwhile existences. So, but that would require the absolute reorganizing of all of the universe's matter. Some might find that completely abhorrent. That it's kind of like we should perhaps be a little bit, less dramatic in terms of how we're going to rework the cosmos. But again, I only illustrate this to kind of to show that we couldn't possibly understand the values and the agendas of an ETI. So again, getting back on point, when it comes to our getting the attention of an ETI through, let's say, an active SETI project, we have absolutely no idea what their reaction would be, what their intentions are, and so on and so forth.
So we are literally working on nothing right now.
I would say not literally on nothing. I think we can again, we're thinking people, we have history to look back on. Maybe anthropomorphizing and doing a little bit of projection isn't a bad thing. Ultimately, what I would say, though, is that we can't possibly know for certain what their values will be like.
I'm happy to be cynical right now.
Well, it's good to be skeptical, and good to be, to a certain degree, it's good to be cynical. But at the same time, I think it's also important to not wallow in that too much. And I'm glad we also discussed some of the potential benefits, let's say, of active SETI. Because I don't want to make it sound like David Brin or myself or the other colleagues that are opposed to the SETI, active SETI project, that we're absolutely certain of this. What we're just trying to say is hold off. let's maybe impose a kind of precautionary principle here, and let's discuss it. And let's not be rash and start to broadcast our presence just quite yet, because I don't think we're ready. Because as this conversation has so beautifully illustrated, we simply do not know.
George, great to have you here, as usual.
My pleasure.
You can find a link to George Dvorsky of the Institute for Ethics and Emerging Technologies and contributing editor at IO9 at the link on our site at skepticallyspeaking.com. And of course, you'll also find links to everywhere else that you can locate us on the internet, including iTunes, so that you can download past shows or subscribe to the program. Thanks for listening, and we'll see you next week on Skeptically Speaking.
Bring it on, the skeptics await your letter. Your call, tweet, homing, pigeon, whatever. Desiree Shell gonna raise a little hell, metaphorically that is. Cause we're skeptically speaking.
Skeptically Speaking is produced and distributed by Suburban Panic Media. Our guest coordinators are Rochelle Saunders and Ed Haynes. Our social media manager is Chelsea Butler. Helen Quivalon is our publications coordinator. Ryan Bromsgrove is our production manager and assistant editor. Josh Witten is our researcher. The show is edited by K.O. Myers. Our theme song was written and recorded by AOK. And I'm your host, Desiree Shell.